All right, let's finish up notes for 4.5b. This section is on integrals of odd and even functions. So just as a reminder, we can always split up a definite integral problem into the sum of smaller parts. So let's say we're given a definite integral from 10 to 3 is equal to 9, and a definite integral from negative 1 to 3 is equal to 5. And it says find the definite integral from negative 1 to 10. Now what we do know is that we can split this up. Definite integral from negative 1 to 10 of f of x dx is equal to the definite integral from negative 1 to 3 of f of x plus the definite integral from 3 to 10 of f of x. Right? We do have this value here, which is given to us being 5. But the definite integral from 3 to 10, we have a variation of that. So the definite integral from 10 to 3 is 9, so therefore the definite integral from 3 to 10 must be equal to negative 9. Remember, if we change the bounds, then we have to pull a negative outside. So 5 minus 9 is equal to negative 4. Okay, just as a reminder, for even and odd functions, even functions, we have symmetry about the y-axis, so anything on one side will be reflected on the other side of the y-axis. So I can think of it as the definite integral from negative a to a, so these two regions, is same as if I just took the integral of from 0 to a and then doubled it. So that's what I have here. So that's just to show the relationship between the two portions for an even function. An odd function has symmetry about the origin, so anything that is on one side will be the opposite on the other. So if I find the definite integral from negative a to a, it will always cancel out to be 0. I'm always going to have a positive portion and a negative portion, and they will always cancel each other out. Okay. Number 3, suppose our g of x is an even function. So remember, we want the graph to be symmetric about the y-axis, where the definite integral from 0 to 3 is equal to 2, and definite integral from negative 4 to negative 3 is equal to positive 4. So I'm going to just draw a graph showing these characteristics, and then see if we can fill out the rest of the information so that we can answer the question. So from 0 to 3, the definite integral from 0 to 3 g of x equals 2. So from 0 to 3, I'm just going to create a region that has positive 2. And then from negative 4 to negative 3, my area will be 4. So negative 4 and negative 3, I'm going to create a region that has definite integral of positive 4. Find the definite integral from negative 4 to positive 3. Okay. Now, we have these pieces of information, but we also know that this function is even. So we know that we can create a graph where both sides are going to be equivalent or mirror images of each other. So if we know this is 2 from 0 to 3, that means from negative 3 to 0, we must also have a positive 2. From negative 4 to negative 3 is positive 4, so 3 to 4 must be also the 4. So now I have all these values that I can use to solve my to find the problem in question here. So the definite integral from negative 4 to positive 3 will be this region here. Okay, so if we add all this up, 4 plus 2 plus 2 will simply give us 8. Okay, example 4. Suppose we have the same function, but now, or the same values given to us, but now we're looking at an odd function. So we want there to be canceling out between both sides of the x-axis, both sides of the y-axis. Okay, so again, what's given to us is from 0 to 3 is a positive 2, and from negative 4 to negative 3 is a positive 4. Now we want this to be an odd function, so we want everything to cancel out on both sides. So if this is positive 2, we know from negative 3 to 0 must be a negative 2. From negative 4 to negative 3 is a 4, so we know that from 3 to 4 must be a negative 4. So now the definite integral from negative 4 to 3 would be this region here. Okay, so we have 4 minus 2 plus 2 will give us a positive 4. All right, last one here, example 5. What's given to us is that our function is even. From 3 to 6, the definite integral of f of x is equal to 7. So I created that here from 3 to 6, positive 7. From negative 6 to 3, the definite integral is equal to 12. So from negative 6 all the way to 3, this whole region is equal to 12. Now I know that this region is 7, so I know that this region must be 7. So now we can figure out what the rest will be, right? If this is 7 and this entire region is 12, then that means 12 minus 7, that means this remaining portion must be equal to 5, right? But remember, this is an even function, so we have to split 5 evenly on both sides of the x-axis, so this must be 2.5 and 2.5, right? So if we look back, double check our work, from negative 6 to 3, we should get a definite integral of 12, and we do. 7 plus 2.5 is 9.5, 9.5 plus 2.5 gives us 12. So now we want to find the definite integral from 0 to 6. So from 0 to 6 is simply going to be the shaded region here. So 2.5 plus 7 is simply 9.5.